Okay, welcome to our community call in April. I hope you're all having a fun and safe time. We have a very simple agenda today. I'm just going to share my screen. And simply, we just thought we'd just do one topic because it's quite a topic that a lot of questions have been asked about in the past. And that is, how does Dapr and Service Meshes work together? And we only literally thought about this yesterday. So we thought, what should we do? We said, well, let's just dive into this topic. And your own decided to put a few slides together in a demo. And then we were going to hopefully have plenty of time to open up to questions because we think that there's a lot of questions to ask about this particular topic. And then as always, I'm going to give you a little update about our release roadmap, where we are, and then we'll have general open Q&A. So that's the agenda for today, very simple. So at this point, I'm going to stop sharing and I'm going to just check that there's anyone else to come in. No, there isn't anyone else. And now at this point, I will hand over to you, Jeroen, and you can present your screen and take it away on service meshes.
Okay, thank you, Mark, and thanks everyone for joining. Really appreciate your time. And I'm really excited to talk about this because like Mark said, we have been getting a lot of asks about Dapr and service meshes, and I personally love those asks. And so we decided to share about some of the things that we've been thinking about, how we view, Dapr and service meshes, talk a little bit about existential cloud native questions, which is always fun. And then we'll show a Kubernetes demo with Linkerd. And we've actually been talking to people from Linkerd, and this is the place to give them a pretty good shout out. So thanks to William and the others, they've been really great to work with. And we all came to some pretty interesting conclusions. And so let's just start with sharing my screen, and let's see a couple of slides. Okay, so let me know when you can see my screen.
We can see your screen.
All right, great. So today's topic is, of no surprise, Dapr and service meshes. And before we talk about, Dapr and service meshes explicitly, let's talk a little bit about the evolution of software, which is a pretty huge topic. No way we can cover this whole today. But at least in my view, the way we're viewing, software is we're going towards an era of more choice with more frameworks, more tools in our toolbox to use to solve our problems, which should, if their promise is correct, give us more agility. Now, whether or not this actually happens is a matter of great debate, which is interesting, and I'd really love to hear from you guys. But let's see how some other people view this. So if we take a look at the SMAC stack, and I think this sort of term was originated from the Mesosphere people a few years back. So this is Spark, Mesos, Akka, Cassandra, and Kafka, mostly an Apache stack besides Akka. And if we look at that, basically it's mostly a JVM-based stack relying on centralized coordination, mostly Zookeeper, for coordinating nodes. It's mostly a Java stack, so very appealing to Java or Scala developers with a really strong emphasis on client SDKs, and it's very much on-premises oriented. Now, this is a really good stack that's in no way presented as being like something ancient. It's still being used today, and it's quite good, but there is an evolution, I think, from there. And while things like Mesos, for example, can run Kubernetes, and Akka and Cassandra and Kafka can run on Kubernetes, and Spark itself has different schedulers. For example, Spark can use Mesos, or it can run on-prem, and it can also use Kubernetes as the scheduler. Those are, they're mostly JVM-based, so you need beefy RAM-based machines, and then you need a couple of, well, at least a quorum of machines for the leader election. So anything that's related to Zookeeper. And then as those frameworks and technologies matured, they did have and are continuing to have more client SDKs, but really the majority of functionality is mostly around Java and Scala. Spark, of course, having client drivers for Python, Java and Scala. And then if we look at the cloud edge native app stack, and the reason why I put edge there is because I personally don't like to use the word cloud native, because edge is pretty important. We can see that there's sort of maybe, you know, an emphasis on components that are being more modular, meaning that you can basically swap out something for something else if you need to, at the minimum amount of time with the minimum amount of work that's required for your operations team or developers to do so. Mostly are API driven. So some of these technologies try to be API driven. This is at least what Dapr is trying to do by having developers consume APIs rather than implementations. Polyglot's important because we see the rise of more and more programming languages, and also like not general purpose programming languages, but you know, some languages that do one thing which they do really well, but then you need to have the breadth of ecosystem for those languages. And then infrastructure agnostic. So, you know, by infrastructure, I sort of mean here like cloud and edge, you know, not necessarily Kubernetes, because we can see, at least in some of the CNCF landscape projects, that there's a heavy bias towards the Kubernetes platform. And with good reason, because it's probably the most widely used container orchestrator, or not probably even. And then being lightweight, because, you know, we can't all assume that every organization or every developer or small startup have ridiculous amounts of money to basically just put into either cloud services which do not grow economically with your load, or, you know, just very beefy VMs to run the infrastructure that you need. And also the lightweight edge is pretty important. So you might want to orchestrate stuff that's running on microcontrollers, for example, and lightweight IoT edge devices. And so frameworks and technologies can't necessarily assume that they're going to be running, you know, with, for example, 2 virtual CPUs as a minimum requirement to run them. But with those kind of tools, and especially with, you know, with the modularity part, there is increased complexity. So great, we now have this modern application stack, and now I just want to come over and deploy my app, but I run into this. And this is the CNCF landscape, right? So, you know, I just want to write an app, and then I'm confronted with this. What do I choose? What are all those things? What do they do for me? And then, you know, if you want to see something quite amusing about this, check out Kelsey's Hightower's stream of tweets from the past week, especially from last night. It's quite amusing and funny. He makes a lot of pretty, I would say, amusing sayings about, you know, the confusion here. And so developers and operators are both presented with all those technologies, and there's complexity increasing. So for example, if we look at the CNCF surveys, we can actually see that if you take a look at complexity here, complexity is on the rise, because that's what you get with, you know, so many new technologies in so many new categories. And so I think I also saw on Twitter someday where somebody actually tried to run half of the CNCF projects on a cluster, and they needed like a 40 CPU cluster or something just to get the infrastructure running, which is insane. And then of course, cultural changes with development teams, which is really a symptom of that. And so complexity is on the rise, and what Dapr and Service Meshes both have in common and what they're working towards is to reduce complexity. But Dapr and a Service Mesh both do it in different ways, and they sort of target different personas, whether it's the application operator or developer persona. So reducing complexity is a key theme here, and we're going to be taking a look at that. So if we take a look at the application code and the hosting infrastructure, what we can see is that we have the developer there on top and the operator at the bottom. So the operator is, of course, closer to the infrastructure layer, and the developer is closer to the application layer. And if we take a look at the service meshes operate mostly, or actually entirely, at the network level. So you get things like resiliency and matrix and tracing with traffic splitting and traffic routing. This is by no means a complete map of everything that a service mesh does, but it's the majority of things. And then if you look at Dapr, Dapr is closer to the application code, where it exposes APIs, unlike a service mesh, for the application to call into for things like service-to-service invocation, state management, pub sub, secret management, bindings and triggers and actors, which are a very specific programming model. And so in the middle there, in the deep purple, which thankfully is a color I can actually see, so in the middle there are the overlaps between what some of the capabilities that Dapr and Service Mesh provide. And we're gonna sort of, deep dive and maybe even have a discussion, hopefully, about those things. So let's start with tracing, for example, because this is, a question. For example, great. So I have a Python application or an ASP.NET Core application, and I'm using Dapr for service-to-service invocation and state management. And then I also have a service mesh. So which one do I use? Do I use Dapr's tracing, or do I use the tracing capabilities of a service mesh? And we talked to our friends from Linkerd, and then they basically told us, well, this one's a no-brainer. I mean, use Dapr's distributed tracing. And the reason is this thing. So take a look at the service architecture on the left side here. We have service A calling to a service B using a mesh proxy, and this is any type of service mesh. And this is a point-to-point communication. So request response, service A is waiting for a response, obviously. Assume it's an HTTP call. And then the application map in terms of tracing will show something like this, right? It'll show service A calling into service B. But in many microservices architecture, we're talking about event-driven architectures where you can actually have, applications talk to one another through pub-sub mechanism without necessarily calling one another. Depending, and this is a heated debate, which I'm not going to get into. Some people think that in microservices, request response between services introduce dependency and coupling between services. So, I think it's an architecture is it's a pretty good mixture of both, depending on what you need. But in that case, if we're using a service mesh and you're introducing pub sub and we're introducing service C here, the application map will remain the same, because the pub sub infrastructure, for example, Azure Event Hubs is an example, the communication will not go through the mesh proxy. It will not have, for example, the tracing headers being given into it, because the SDK is on the client side. The mesh proxy will not know how to treat it. And then we basically get an application map, which doesn't really give us a whole picture of what we do. So service meshes are really good with tracing when it comes to service-to-service communications. Whereas if we run it with Dapr, for example, tracing specifically, you will get that whole map, because Dapr provides end-to-end tracing, both for service-to-service communications and asynchronous communications. So you will get tracing end-to-end, and you'll get a complete application map. So this is one example. And if you're thinking about using both, there is a guidance here which we're going to release. Because tracing is sort of an expensive operation in terms of performance, you might not want to use tracing, for both service mesh and Dapr turned on. Where this is not true, for example, is metrics. So the next question that we're coming into is, and I'm just going to go back here. So we have metrics here. And people will ask, well, which metrics do I use? Do I use Dapr, or do I use service mesh metrics? And what I think is that you need to keep metrics enabled for both, because metrics, unlike tracing, which are a per call sort of computation, metrics are aggregatable. So they're being aggregated, and with modular stacks like Prometheus, which actually come and poll the underlying container or application, there isn't a lot of overhead there. And you would actually want metrics for both your service mesh and Dapr if you're running them side by side, because metrics will actually be able to show you if you're having bottlenecks in the service mesh or with Dapr. So if you're using a service mesh in Dapr and you're only relying on metrics for Dapr, for example, you won't be able to see that something might be wrong with your service mesh, because your memory is now exceeding some threshold. So metrics for both are recommended to be kept if you're using both. And now the other thing is resiliency. So resiliency is stuff like circuit breakers and retries. And because circuit breaker is something that you don't normally find on all service meshes, and you can't really claim that circuit breaking is something common to all service meshes, especially if you're looking at things like Linkerd and Istio. Um, we'll talk about retries. And so, retries for Dapr and Service Meshes work sort of the same, except there's one big difference there. And the difference being is that you can apply these retry policies with a service mesh on a per endpoint call. So you basically configure a service, and then for that service, you'll be able to configure some retry policy. Whereas with Dapr, because it exposes an API endpoint, you can set a retry policy on a per call basis. For Dapr, this is currently true for state management, where you can talk to some database and you can tell Dapr to use, for example, an exponential backoff retry algorithm or a linear backoff algorithm and give it some parameters, and Dapr will basically include that thing. That retry policy. Now, why is per call retry policy important? Let's say that you're talking to some other service, to service B from service A, and it's an internet movie database sort of API. And so when you're querying, for example, for thousands of movies, you might say, hey, waiting 30 seconds for this specific query to the other service, that might take 30 seconds. So I want to set a per retry policy on that. And if I'm using a query parameter when I'm calling the other service for, between 1 to 100 movies to get back from the other service, then something like 2 or 3 seconds timeout is all I'm willing to wait in order to not have my application freeze and busy and have threads just hanging in there. So this is in regards to resiliency and timeouts with a per endpoint or a per call basis. And MTLS, mutual TLS, really is something that's quite, I think, really similar to how service meshes and Dapr do it. And the answer there is that, depending on very specific features which you might want, you should, based on those specific, capabilities or feats, you should basically decide. Because, for example, the way that Dapr and Linkerd do MTLS is roughly the same. They have strong identities on Kubernetes. Using service accounts tokens for pods. Dapr MTLS runs outside of Kubernetes. So this is one differentiation. So you can use the Dapr Sentry service for mutual authentication and provide mutual authentication for Dapr services running, for example, on a Kubernetes cluster and talking to, for example, VMs that are running outside of the cluster, but in the same network. So Dapr MTLS can run outside of it. Linkerd one can also do that. But that's one difference. And for example, there are a bunch of small differences which really require you to look into how service mesh or Dapr will do mutual authentication and just decide based on that. For example, Dapr doesn't do RSA keys; it does elliptic curve type of encryptions, and it uses non-permissive MTLS. So Dapr actually requires that if MTLS is enabled, Dapr will make sure that services that do not have MTLS will fail on invoking your service. So it's not a permissive mode. It's basically an on-demand. It's a TLS required mode. Okay, so now we can, I think, go into a demo, and then we can just open it up for questions. And I see there's some stuff in the window. So let's go to a Dapr and Linkerd demo. All right, so I talked about complexity. So, when I tried to do this, I thought, hey, it might be pretty complex to install Dapr and Linkerd together. And granted, I've really only done this twice. So bear with me if I get this wrong. So I have a Kubernetes cluster here, and I have Redis running, nothing else. And what I'm going to do now is install Dapr and install Linkerd, and I'm going to use Linkerde's mutual TLS and not Dapr's. So I'm going to show you how to install both of them from the beginning so that everything is clear and nothing remains hidden. So let's get initiated into those secrets. So I'm going to install Dapr here, and this is just a regular help install, and I'm basically telling Dapr enable MTLS, or actually disable MTLS with this flag here. So I'm just going to kick this off, and wait a second. And we can see that Dapr is installed. So if we take a look at the pods, and we can see that Dapr is already running. By the way, something nice that is going to be released in the upcoming Dapr CLI is you can now do Dapr status -K, and we will basically show you the health of all of the control plane. So you can see all the control plane pods running inside your cluster, see if they're healthy or not, see their status, and if they're not healthy, the exact reason for error will appear here. So this is kind of nice. So we installed Dapr, which was pretty simple. And now the next step is to install Linkerd. So I'm going to use the Linkerd install CLI. And quite a few resources are being created here. And I know this looks like a lot, but it's actually very few compared to some other service meshes around here. And so we have Linkerd basically installed, and I can do, I don't remember really, but let's do Linkerd. I think it's check. So we will wait for Linkerd to be up and running. And let's stop that. Oh, this is Prometheus. Yeah. Okay, cool. So everything seems to be up and running with Linkerd, right? Not missing any green V's. All right, and we can see that the Linkerd identity is configured, the trust roots are configured, the issuer certs are configured, and basically we should be good to go. So for those of you who don't know the Dapr go-to demo, this is our distributed calculator sample, which is a calculator front end, which uses 4 microservices for doing the operations for the calculator. For example, multiplying is with Python, dividing is with Node.js, adding is with Go, and subtracting is with C#. So let's go to the samples, and we'll take a look at those files here. So the first thing I have here is the Redis component for Dapr. And this is basically the Redis host, and this is installing the Redis component store for Dapr to be able to save state. So this is pretty simple. And this is the subtractor application. So we can see the annotations here. We have Dapr IO enabled, which tells Dapr to inject the sidecar. We have the ID and the port. And what's new here is the Linkerd IO inject flag, which is basically telling Linkerd to inject the Linkerd proxy inside the pod. And the same thing for Go, for Node, and for Python. But for the React calculator, I added something special. I added a Linkerd configuration, which basically says for the 6379 port, which is the Redis port, skip, making it go through the proxy. And that's because this is going straight to the database, so there is no reason why it should go through Linkerd in this case, because the Redis pod is not being injected with the Linkerd proxy, and it's not HTTP traffic, it's TCP traffic with the Redis client library, so there is no need for that thing. So basically, for any request that goes out of the request calculator pod, we're essentially bypassing Linkerd, which is pretty good for this scenario. So what we need to do now is basically just deploy that. And all my applications are created. So if I go back here, we can see that we now have 3 containers inside our pod. So this is the application pod, Dapr, and Linkerd all running together in the same pod. So let's wait until they're all running, and we can see they're all running. And we can take one pod and look at the Dapr logs. And we can see that MTLS is disabled. With Dapr, actually, for those of you who don't know, we can actually do Dapr MTLS -K. And the CLI will just tell us that mutual TLS is disabled in the cluster right now. So we have MTLS through Linkerd. So let's start by going to the calculator front end, and I'm going to port forward to the calculator front end service here for port 5000. And so I will go here. And first of all, we can see that, well, the app is working because it's been immortalized. It remembers the state of the calculator from the last run. Now let's see if we can actually have our services talk to one another with Dapr. So the React calculator will use Dapr's reverse proxy and service discovery mechanism to reach other services. So let's do 9 plus 3, and we can see that it's actually working. And I'm just going to do a bunch of requests here. And the reason why I'm going to do a whole bunch of requests is to basically bypass the cold start that some of the languages have. And I'm certainly not going to tell you which language has the worst cold start problem. You can guess if you want to. And so this is going to be important because we're going to take a look at the latencies in the dashboard in just a sec.
Is that Node, the cold start of Node?
Well, Node has really weird latency spikes, which you sometimes see. That's true, but I'm not going to give any more information on that. Okay, so we have some calls running, and what we can do now is basically do Linkerd dashboard, and let's make sure that everything's running. And so this is the this is the Linkerd namespace. Let's click the default namespace. And we can actually see that we have this nice, weird-looking pentaheader type of thing here. So Linkerd is actually tracing all the calls between the calculated front end and the and all the other applications. So we can actually see the latencies here, and you know the 99th percentile latency is about 2 or 3 seconds. The calculated front end has 3 seconds because it's saving state. And you know, this is sort of like the average. So this is interesting because those 2 milliseconds are an application calling the Dapr sidecar, then Dapr's traffic being hijacked by the Linkerd proxy. So it's Dapr to Linkerd. Then it's a cross-pod communication between Linkerd proxy to the other Linkerd proxy. Then it's that Linkerd proxy to the Dapr sidecar, and then from the Dapr sidecar to the application all the way back. So, you know, we're going to release some numbers. Linkerd already published their performance numbers for added latency, but I can pretty much say that from what I've tested currently, the added latency for Linkerd and Dapr together are sub-millisecond. And so we're gonna be working on performance tests, and we're gonna publish numbers for Dapr. In regards to sort of, you know, the same performance benchmarks which you see published by both Linkerd and Istio. So this is a pretty good thing, and we can see that all of our success rates are great, looking great. We can see the requests per second here. And so, you know, this tracing with Linkerd or Istio, they can go to a specific set of distributed tracing stores. Dapr's approach is to be highly pluggable. So, you know, if you know Dapr, you can basically plug in components. So, you know, Linkerd currently, I think, supports Jaeger and a bunch of other stores. You can also write, you know, components for Dapr to basically plug into Azure Application Insights or AWS X-Ray or whatever exporter you like. And so we can pretty much see that, you know, you can configure tracing to be on and off both with Dapr and the service mesh. So you can really have this complementary type of architecture where you can switch one thing off in either Dapr or a service mesh. And, you know, here we actually saw all the requests traveling through Dapr going through the service mesh. But we can also run it in a different kind of way. We can actually configure Dapr to just be something that takes the requests that are coming in, not through the service mesh. And the way we do this is we'd basically, for example, take this thing here, and we will just change skip outbound ports to skip inbound ports. And here I can basically just put the Dapr gRPC internal endpoint. So this is the endpoint, sorry, the port on Kubernetes that Dapr uses from a sidecar to sidecar invocation. And what this means is that when Dapr calls Dapr, the Linkerd proxy will not be intercepting that call. So, you know, you can have some architecture where requests that are coming not through Dapr to the application will be handled by the service mesh. Requests that are outgoing or incoming through Dapr will be handled by Dapr. Matrix, because it's not it's not a high performance degradation, can be enabled on both. And then distributed tracing, depending on your use case, you can choose one or the other, or you can pretty much use both. So this is really just, because we don't have a lot of time, we really want to open up discussion. This sample really goes to show you that it's pretty simple to set those things up. And of course, there's a lot more to show here, but we are going to release documentation and guides. And of course, we'd want to hear from all of you. So let's open it up for questions and discussions. So I'm going to stop sharing now.
Well, thanks, Yaron. That's really good.
Yeah.
I think it was good, pretty good demo of how Linkerd and Dapr work together and the capabilities of both. So, I mean, yes, at this point, given that Service Mesh and Dapr are often got lots of overlapping questions and things, hopefully that answered lots of things. I'd love to hear from people. Does this sort of answer the questions of the differences between the two? Or is there any particular areas that we haven't covered that you'd be interested in knowing more about?
Yep.
Yes, this is Steve. This is awesome. Thanks for sharing this. I was curious. So I definitely saw some overlapping kind of features and some benefits of where you could use a service mesh where you could potentially tie one. I think the traceability and the dashboards and all those things are interesting. I was curious. Are there any other? If you were with the customer and they said, "Hey, we need feature X," you would point them at a service mesh. Any other features beyond kind of what you showed today? And then second, I was curious. I have a lot of customers who are looking at service meshes for canary deployment, leveraging something like Flagger, on top of the service mesh. I don't think you'd really need that with Dapr because of the features that it provides, but I was curious if that's the case.
Yeah, so that's very much true. So in the layer diagram that we showed traffic management and traffic splitting, which is part of the stuff that Service Mesh does on the network level that Dapr doesn't do, and probably won't. And so those type of things are really in common with canary deployments. So this is one place, if you want to do traffic splitting and network routing, of course Dapr doesn't do that. Then you would use a service mesh. And for example, you would use Dapr to build out your application, save state, do secret management, whatever. And for the operational network concerns like canary deployments, of course, you'll use a service mesh. And that's a really good example where the two are really complementary.
Cool, thank you.
No problem.
Yeah, I think generally it's worth pointing out that we think of this as sort of, there are 4 layers. There's the underlying hosting platform itself, such as Kubernetes or Docker Swarm that does the hosting activation on it. And then you can layer on top of that things that solve the complexity around networking, such as Service Mesh, or auto-scaling, such as Kda and Knative, and those things. And then you can put on top of that Dapr, which provides the capabilities for your application, and then you write your code on that. So that's how we think about that sort of layering, and then hopefully that reduces the complexity of having to build a lot of these capabilities into your code, and you can just take advantage of this sort of stack of technologies.
Just another quick question. So you shared that there was that port that you were kind of ignoring to enable Dapr to continue to run on Linkerd. Were there any other kind of sneaky gotchas that you ran into, or pain points you think that we'll see customers run into, or was it pretty much just as straightforward as what you ran through today?
Well, there is one there is one gotcha, and you know what? I'll share my screen again, and let's take a look at that, and it'll also be a trivia question to everyone. All right. Let me know when you can see my terminal.
Yes.
Got it.
All right, great. So Linkerd has this really great way of showing you, for example, security, right? So I think it's called Linkerd Edge, yeah. And so this really shows you, the edges where you have the source and the destination. So if you take a look at the example which we just showed, you can see the calculator front end is calling all the services, and they're all secured. But you also have the Dapr control plane, which the Dapr sidecar is calling to the Dapr control plane, and these are not secured. Why do you think that is? we don't have prizes for the person with the correct answer, but you'll have our token of, I don't know, appreciation, whatever. So yeah, I'm gonna give 1 minute here for.
Something missing in core DNS?
No, it's like somewhat, you know, related, but no, not in core DNS. Okay, so the reason why there is no MTLS provided between the Dapr sidecars and the Dapr operator is because we have the Linkerd proxy inside of our application pods, but we don't have the Linkerd proxy inside of the Dapr control plane, right? So if you take a look at the pods inside the Dapr control plane, I can see they have one pod, right? They have the control plane pod. So there is no Linkerd proxy here. So if I wanted end-to-end TLS between the Dapr sidecar and the Dapr operator 2, I would need to basically annotate the Dapr Helm chart with the Linkerd annotations, which is that one. And then basically inject Linkerd into the Dapr system, and then we would basically see, you know, end-to-end stuff. Also, if we run the Linkerd dashboard again, something that's weird in the distributed tracing is that I don't really remember how I got to it, but yeah, let's do that. Let's go to calculated front end. And so, yeah, so we don't have really live calls. Let's start implementing calls so that we can see what I'm talking about. All right, let's go here and so I'm basically just making some calls so that I can demonstrate some of the stuff. Okay, so we see the live calls here now, and we can see that where the calls are going in terms of, whoops, I didn't want to click that. So we can see where the calls are going. Yeah, let me just click that again. Yeah, that's kind of weird dashboard thing. All right, let's try and do some more calls. I don't know why that disappeared. Oh. Okay, yeah, so we see those post methods, and we see that the path is something quite weird, right? So we can see where they're going. So they're going from this calculator deployment to the other deployment, but we see that the path is actually something called Dapr internal call local. And this is because it's tracking the internal API endpoint that the Dapr sidecars are calling. So the information about the end user endpoint is not actually propagated. And this is also why we'd recommend to use Dapr's distributed tracing instead for path-based resolution instead of Linkerd. So this is, you know, one additional gotcha. Now this maybe could be fixed, but you know, this is something that where if you're not really aware of what's going on, you're like, huh, what's this? All right, more questions? There's a question, is W3C trace?
Yeah, we get asked a question, is
yeah.
W3C tracing going to be supported?
All right, yeah, I just pulled up a bit.
Yeah.
Okay.
Okay, great.
Yeah.
Well, at that point then, I mean, feel free, we'll have an open Q&A in a moment. I'll just switch to talk about, thanks, Jeroen, that's fantastic. And as Jeroen said, we're going to turn this into a set of docs for showing how Linkerd and Dapr work together. A couple of weeks ago, we also did a talk of how Nginx and ingress controllers can hook up with Dapr as well, and you can Dapprize those. We're putting that into a set of docs as well, and you know, we're going to link to these videos as well. So hopefully both of them will work together, so you can actually see some of the in action from the docs. But if there are any other docs you'd like to see that you'd see like covered, post them inside the issues inside the docs repo, because we often get asked about particular topics, and we always try to make sure we get docs to show good how-tos about how to make Dapr and work with these other technologies, because we're trying to make it sure it's very collaborative with these other things like service meshes and ingress proxies and hosting platforms. So I'm just going to share my screen here now. And, I was just going to give you a little update about where we are with some of our planning. So we are now into the 0.70 milestone plan, which we kind of numbered based upon the runtime release, but actually incorporates not just the runtime, but also the SDKs and our other repos as well. But focusing on the runtime in particular, the main things that we're trying to address in this milestone. So you'll see that we're a couple of weeks into this milestone here, and we put a date that we're going to do a release of this at the moment for the 30th of April, where we have a sort of a code freeze a few days beforehand. And pretty much we're carrying on along on our fundamentals theme, where we address the top priority bugs that get released, and you can go look at these queries inside this issue inside here, so 1374. And the fundamentals we talk about here are continuing along the work on our observability, for example, supporting the W3C specification for eventing, making sure that we have good diagnostics and trace events that come out and go into all of the diagnostic viewers such as Zipkin and App Insights and Azure Monitor inside Azure, as well as other cloud providers, and basically provide good metrics, good tracing and good logging. We started on long haul tests. This is so we have an application that runs for a long time. We can start to find things like memory leaks and underlying long haul issues where long running applications can sometimes find particular bugs. So that's, and then end-to-end tests where we kind of cross between the Dapr building blocks. We call one from another and see if there are end-to-end issues because of perf or latency or feature-wise. We did quite a bit about security in our last two calls. And then another thing that Jeroen mentioned that we're just starting in this milestone is to start to pull together a perf and scale set of tests. If you actually go and click on these links, you'll see that it takes you to a list of performance and scale tests you can see here. And then all of these ones, this is a list of all of them. We start to pull them into a particular milestone. So here's the 0.7 milestone. You can see here's the things that we pull into the milestone that we think we need to get done. Here's some of the work that's been worked on at the moment. This stuff has been PR'd and is in the middle of review. And then this work that's completed. So feel free to look through this list of outstanding work. You can see it on those views around the fundamentals, the observability, security, long haul, perf tests, and security, as well as sort of the Pry1 bugs that have been reported, which are ones that we consider are impactful on particular scenarios. So feel free to comment, feel free to also jump in, and if there is work inside this to-do list that you just want to jump on, you see that large numbers of this is just not allocated today. We're open to all sorts of contributions, and if there's even things that are not on this list that you want to work on, that's fine by us. We are very open and collaborative. We don't mind you working on anything that's an issue in any of the repos that you can come across. I talked about performance and scale here in terms of the list of milestones. So that's kind of the milestone plan that we look at today, and we're going to continue along this cadence of trying to release, once a month or every week around these things. So that's the plan for that side of things. As always, feel free to go into our issues list and look through the thing. I would also suggest that inside here there are a number of proposals as well. That are being worked through at this point in time, and so always feel free to comment on some of the proposals. For example, one of them at the moment is this simplified tracing and configuration, where we're just, as part of the observability work that we're doing, we're just trying to make tracing a little bit simpler to use than it is today in terms of the configuration settings. So feel free to kind of go into this proposal and comment on it and give some of your feedback. And any of these other proposals inside here that you see pulled into the milestone, or actually any of these proposals that you think that are interesting to your scenarios around these. So we encourage you to look at these. Okay, so at that point, I'm going to start sharing. This is a time now for any open Q&A. Feel free to ask us anything that you want, milestone-wise, API-wise, capability-wise, something that's on top of your mind that you want to see or don't like about Dapr, or anything else that you want to suggest that we do in future community calls. Looking at some of the things posted inside here. Oh, Carlos wrote it. I wrote a post on the Nginx one. Yes, please go and try this out. Carlos did a great post where he took the Nginx demo that we did and turned it into a post. Actually, I went through it. It was very good, Carlos. It was pretty clear about how to enable Nginx inside there.
Hey, thank you. I have a question regarding the API. You hear me, right?
Yes, we can hear you.
Okay. Yeah. It's about the secret API.
Yes.
Secrets API. Okay. Right now, we can ask for one secret at a time, and actually, I have a client back here in Spain that needs to to retrieve more secrets, or they actually create key vaults in Azure. Specifically to retrieve a bunch of secrets on one call. So my proposal will be to extend the secret API to have a method where you can retrieve each and every secret that's in the store on one call. Because, for instance, Azure Key Vault has it has I lost the word. Is the more you call it, it has like a threshold there, and there's a performance hit. So that will be a proposal for if you mind, I can put it in the GitHub and well further discuss it there.
Yeah, perfect. Yeah, I mean you're right. A key vault has throttling on it, so you can't hit it.
Yeah, throttling is the word. Sorry about that.
Yeah, it throttles the number of calls inside there. And you're right, getting one secret at a time. If you want to get a list of secrets, that sounds a great addition, actually. So, give me back a list of the secret keys and give them to me. Yes. Feel free to put that in as an issue and even start working on the PR. That sounds a great idea.
Yeah. Okay. Sure. Thanks.
So another question has just been asked. Any plans to migrate from Cloud Events v0.3 spec to the v1.0 spec that was released last October?
Okay, so I can comment on that. Actually, if you look at the spec, we already support the 1.0 spec. It's the same, essentially. We just need to change our documentation and our code documentation, I think, but we are compliant with 1.0. If you find that we're not, please raise an issue because we should be. But thanks for raising this, Dwayne.
All right, Doc's wrong at the moment. I thought they said 3.1 spec.
No, they say 0.3.
Oh, they do? Oh, okay. I'll get that fixed today. Thanks for pointing that out.
And yeah, so I'm gonna make life a bit tougher for us, the Dapr guys. So Dave Kompel, how about that pub/sub dynamic registration there, huh?
Yeah, what about it?
Yeah, what about it? So that's something personally that I would want to see go into 0.8. So, if you can help us flesh that out a little bit more in regards to, how the API would look like. And so we can re-engage in that conversation, that'd be pretty helpful.
Sure. Yeah, I think you know how to get a hold of me.
Yep.
So feel free anytime.
Okay.
And I know Aman took some notes about how to actually implement and plummet back into the SDK on a conversation we had.
All right, cool. So we can bring that into the larger conversation.
Yeah, isn't 1.8 a little?
1.8? No, I said 0.8, but I don't know. I mean
0.8. I mean.
Yeah, I mean, what I'm saying is personally, I would want to see this before we hit 1.0 because I think.
Oh yeah, definitely before 1.0.
Yeah, I think it's important, and this is something that we'd like to see. So for everyone here, if you could look up the issue for dynamic pub/sub registrations, that's something we'd like to tackle, and we could use all of your help in deciding how the API looks like. So help us shape it.
And yeah, and that could also be used as an easy way to plumb actor events in the SDKs.
Yes, that would also be used for that. Yeah, it could also be used for that.
And the only reason I suggest that, not do it in the actual actor API, is because limitations of different languages in their SDKs to, you know, some things don't have the concept of events.
Yeah, no, it probably needs to be in the Dapr runtime. I agree.
Oh, that might be a little hard to implement across all the SDKs you might want to implement actors for, since the idea of events don't exist in a lot of those languages.
Yeah, I mean, like pub sub registrations in general, so that you can call into Dapr to subscribe, and then
Right,
yeah.
and specifically a dynamic name, you know,
yes,
or unique name,
correct.
unique name subscription, where you just say, I want a subscription to this unique name. It returns the unique name to guarantee that there's only you and the only receiver of it. And that gives you basically a way of doing any kind of dynamic events, where it's important the event get delivered to the instance of the thing that set it up.
So Dave and I had a chat around a couple of months ago on how to implement service fabric like actor events and actors, and then dynamic pub sub can enable that. So when the client says, hey, I'm interested in an event from this actor, the SDK would go and subscribe for that particular topic. And then the runtime can start publishing events to that topic that would be delivered to the actor SDKs on the client side.
Right.
So that was the gist of it.
Has anybody even thought about how to do an actor SDK for a non-object-oriented language?
So I think that's
For
a
actors?
question to the world. I've never seen an actor framework for a non-object-oriented language. That'd be interesting.
Okay, that was my only concern about putting actor events into the runtime, is that it would preclude, you know, other languages that you might want to extend it to that don't have an event or object model.
Yeah, I only meant to put the dynamic registration capabilities in the runtime.
Right.
Not the
Oh,
actor.
okay. Yeah.
Yeah. But you know, that's interesting because, for example, we've been doing some work with Azure Functions, and with some upcoming work you're going to see with Dapr and Azure Functions, you sort of will be able to say that a specific instance of a function can be made stateful, and you know, with configuring Dapr for rate limiting, which is one of the features that Dapr has, you can sort of get like a serialized access to a function which is stateful. So this is, you know, you might think of this like as like an actor function in a way.
Yes.
Right, exactly.
All right, I think we're...
Yeah, I think we're at time. Yes, that'll be an interesting future topic. So after our next community call will be in 2 weeks' time. That'll be just before our 0.7 release. So we'll probably be talking quite a bit about what's in that release. And then the one after that, we'll probably go into quite a bit around the work that we're doing to collaborate with the Azure Functions team and also the Azure Logic Apps team to show how Dapr and Logic Apps and Dapr and Azure Functions integrate as frameworks and take advantage of Dapr to bring capabilities to those. And we'll probably do that sometime in the middle of May, which will be very cool because then it shows how you can do workflow type applications with the capabilities of Dapr inside there. But thank you very much, Guy, everyone, and see you in 2 weeks' time.
Cool. Thanks, everyone. Bye.